Hi, this is Antosh Dade. You are at Data Communication video lecture series. In this video, we are going to explore the concepts and terminologies used in data communication subject. Data transmission occurs between transmitter and receiver over some transmission medium. The transmission medium is classified as guided and unguided. In guided media, the waves are guided along the physical path, and examples are coaxial cable, fiber cable, twisted pair cable. In the unguided media, also called as wireless, and here waves are not guided. Examples are microwaves, radio waves, infrared waves, and waves propagation through air, vacuum, etc. Types of networks. Direct link is a link or path between transmitter and receiver with no intermediate devices other than amplifiers or repeaters to boost the signal in guided as well as in unguided media. Whereas point-to-point is a direct link between two devices and the medium is shared between the only two devices in guided transmission medium. Multi-point is a medium shared between more than two devices in guided transmission medium. Here you can see the link is shared between three devices. Data transmission modes. The transmission may be simplex, half duplex, full duplex. In simplex, the signal is transmitted in only one direction. An excellent example of simplex communication is radio. In, in the half duplex, both the station may transmit but only one at a time, since only a single communication channel is needed, which is shared alternatively between two directions. For example, a walkie-talkie requires only a single frequency for bidirectional communication. In the full duplex, both the station may transmit simultaneously. An example is a cell phone, which is a full duplex device, requires two frequencies to carry the two simultaneous voice channels, one in each direction. Let us explore frequency, spectrum, and bandwidth. Frequency is the number of occurrence of a repeating event per unit of time, or is the rate at which the signal repeats. And we can see the signal is continuously repeating. The spectrum of signal is a range of frequency that it contains. Like here, it is an electromagnetic spectrum. It contains a range of frequency. This is a visible frequency spectrum. The absolute bandwidth of a signal is the width of the spectrum, and a signal contains relatively narrow band of frequencies. This band is referred to as effective bandwidth or just bandwidth. And in this case, this is an effective bandwidth or bandwidth. Always higher frequency minus lower frequency. The bandwidth can also be defined as the maximum rate of data transfer across a given path. The signal is a function of time, known as time domain, and can also be expressed as a function of frequency, known as frequency domain. We'll explore time domain and frequency domain in the next slides. Here you can see the signal is represented in time domain as well as frequency domain. You can see amplitude versus time, amplitude versus frequency. Let us explore time domain concept. Signals are viewed as a function of time, and signals can be analog signal, digital signal, and periodic signal. In case of analog signal, intensity varies in a smooth fashion over time. Here we can see the intensity varies in a smooth fashion is a continuous signal, whereas in digital signal, intensity maintains a constant level for some period of time and then abruptly changes to another constant level. There are two constant levels in case of digital signal, high and low, high and low. Periodic signal, in which the same signal patterns repeats over time. The signal is continuous, it's called sine wave. Here you can see the signal is continuous, it is called as sine wave. And a discrete signal is called as square wave. The discrete signal is called as square wave. The sine wave is a fundamental periodic signal, can be represented by three parameters: peak amplitude, frequency, phase. Peak amplitude, it is the maximum value or a strength of a signal over time. This value is measured in volt, and in this case, the peak amplitude. Maximum value or strength of a signal over time. Frequency is the rate at which the signal repeats, and is always measured in hertz or cycles per second. Like here in this case, in 1 second, this cycle repeats. 1 cycle it repeats. So here frequency is 1 second, 1 hertz. Phase is a measure of relative position in time with signal. Example, phase is measured in radians. In this case, the phase is 0 degree. As the signal starts with 0th second signal starts with 0 degree. In period, it is a time taken for one repetition, hence it is always 1 by f. Here few examples are there. There are four graphs. In this first figure, the amplitude is 1. You can see 0, 1, and frequency is also 1. 1 second, there is 1 cycle. The second figure, amplitude is 5.5, and frequency is again 1 cycle per second, and here phase is 0. In this case also phase is 0. In third figure, the amplitude is 1 and frequency is 2. Here you can see there are two cycles. This is first cycle, this is second cycle, and phase is a 0 degree. In the fourth figure, the amplitude is again 1, whereas and frequency is also 1. You can see 1 second there are 1 cycle, and whereas phase is 45 or pi by 4. You can see the relative position of signal particular time 0 second is 45 degree. That is pi by 4. The wavelength of a signal is the distance occupied by a single cycle, or the distance between 2 points of corresponding phase of 2 consecutive cycles. Here you can see there is a distance between 2 points of corresponding phases of 2 consecutive cycles. This is called wavelength. Different waves are having different wavelength, like visible waves varies from 400 nanometer to 750 nanometer, like the red light waves varies from 700 nanometer to 150 nanometer. Let us explore frequency domain concept. Any electromagnetic signal consists of collection of a periodic analog signals of different amplitudes, frequencies, and phase. Here you can see in this figure there are three periodic analog signals with different amplitude, frequency, and phases. The frequency domain function specifies the peak amplitude of the constituent frequency of the signal. Here you can see this frequency domain concept view. In the case of frequency domain concept, it specifies the peak amplitude of the constituent frequencies of signals, like this periodic analog signal having this peak amplitude, this periodic analog signal having this amplitude, this is having this. So frequency, in case of frequency domain, it is amplitude versus frequency, whereas in time domain it is amplitude versus time, and it will represent all addition of all three frequencies. Here you can represent, here you can see the final frequency in case of time domain, and here the peak amplitude of each constituent frequencies in case of frequency domain. Here are a few examples. Here you can see the periodic signal is represented mathematically sine 2 pi by ft. Here the amplitude is 1 and frequency is 1 Hz. In this case, amplitude is less than 0.5, that is 1 by 3, and frequency is 3. After adding these two frequencies, resulting frequency is something like this. If you again add these two frequencies, the resulting cycle will be just like this. If you go on adding the multiple frequencies, the resulting cycle will be something like a square wave. Thank you for watching this video. We'll meet in the next video on analog and digital data transmission of this data communication video series. Have a good day.